I'm going to give sort of an overview of how do we think and how do we get there. In 1970, I graduated from college. I'd protested a bunch in college, figured that maybe there wasn't a good career in that, and somehow stumbled into architecture as a way to save the planet and change the world. And about a year, I went to a lecture on renewable energy by a guy named Steve Baer, who built these domes out in the desert that were totally solar heated. And I said, that's what I'm doing the rest of my life. And so I was at the University of Pennsylvania at that time. The teachers thought, renewable energy was probably the worst idea that, you could come up with. Totally violated all aesthetics and was just a really bad idea. So after a year, I decided that, the teachers weren't that smart, and it was time to go off and build not only a solar building, but a solar community in Vermont, where it's one of the cloudiest and coldest places in the country. Our logic wasn't necessarily always that great. And a year after that, somebody stopped by and said, hey, let's, my brother and I are going down to Machu Picchu in Peru on motorcycles. What do you think? And so I said, sure, that sounds good. When we got to Panama, we realized there's no road actually from Panama to South America. We still did get to Machu Picchu, and for me it was sort of the second real milestone in my thinking. I got there, and here's this place that has these terraces, growing food, going into a green in the middle of the community, and in an environment that is just unbelievably spectacular. I mean, I was just totally blown away when I was there. And there were a few things. One, it just struck me that beauty comes from how we live our whole lives. It's not just out of the architecture and what we do. And two, it sort of made it clear to me, here's this incredible place, and they didn't have any fossil fuels. So we and others have come up with the glitzy new term of net zero, like we've invented something. The fact is that that's the way the world has been. And that really has been what has fueled my passion, my career, and what I've done. In the 1970s, I did solar homes. Ronald Reagan got elected, and that didn't seem like the viable strategy anymore. And I went into looking at energy conservation, indoor air quality, building science, healthy building design. So I still kept the focus in the ways that I was able to keep that. And then around 2000, the world started to change, at least from my perspective. People in the high performance building mode and Nessie and others really did start to push things in a much more serious direction. And then with the drop in solar prices, the whole solar revolution has come and has been amazing. So our practice now basically does net zero buildings or net zero ready buildings, or what we call carbon neutral buildings, meaning that there may be wood involved in heating of the buildings or the energy of the buildings. And that's pretty much all that we do. As we did that and we started doing larger buildings, we ended up writing the book that was mentioned. And as a way of, how do we take what we've learned in terms of not just single-family homes, but in terms of larger buildings, ultimately communities, ultimately the entire planet, and really transform things at a much larger scale. So that's really been my career. This is the the book that we ended up writing. For us, just the simple definition of because I realized I have an add-on here. International Living Futures Institute definition. There's now, a whole bunch of different definitions of net zero. Ours, though, is actually pretty simple. It's really any building, it's any project, it's any community, and ultimately it's the planet that produces more energy than it consumes on an annual basis, and that energy is renewably powered energy. I think we want something simple. So the other things that have fueled my sort of thinking is just that, as architects, we are concerned with the environment. And in terms of how we live as human beings, I think of it as we live in certain kinds of worlds. Like we have the world of our family, which shows up in our home. We have the world of work, which shows up in our office building, spiritual space. And there's those different kinds of worlds that we're involved in. And obviously, as architects, we're concerned about creating the future and what those worlds can look like. And I think it's not just as architects, but it's also, that's what everybody does. The unique thing about human beings is that we invent a future that wasn't there without our being there. Sometimes it's not such a good future, but sometimes it is. So I think of the basis of inventing the future in design is like, what is the mess? What's the mess that we inherit? We go and talk to a client, and there's just the chaos of whatever their current situation is that somehow we sort through. We can look at that if we look at the planet as well. I mean, obviously, we hear about climate change, but there's pollution, there's habitat destruction, species extinction. I mean, the list could go on and can become quite overwhelming. So how do we create a new order out of that chaos? For me, there's the mess that we see. And like if we're an architect or just looking at climate change by itself, and we're going to solve that, or we're going to solve inequity, overpopulation, you're not really going to solve it by yourself. So for me, it's about trying to create something that's underneath that mess, and what are those things? So one, for me, is sort of fundamental piece is, in high school you learn about entropy. Like everything in the universe is going from order to disorder, and it looks pretty depressing. And then at some point you wake up and you say, and I look out at the flowers and I look out at all the other stuff in the universe, it seems like things have actually gone the other way. For me, that's the fundamental piece of when we're doing work in our office. Is this something that's headed as a positive step to the future, or is it headed towards disintegration and less order? Another part, I think, of that puzzle that's somewhat connected is for the last 500 years, the way that we think, I think, has been a real problem. The whole mechanistic view of Newton, Descartes, and others made us think about disaggregating things into little pieces. They're disconnected. We became disconnected from the environment. And I think as many people talk about, it's how do we reconnect in a different way that's living systems based. So we were talking about, how do we get from the mess to a beautiful future? So for me, underneath all of that mess is the sources of energy. We think of the climate change aspect. Obviously, energy has to do with the power that we have. But you can look at energy as like food that actually is nurturing, or is what's actually creating growth. One might think that the overpopulation of the planet actually may be connected to the fact that we've had fossil fuel. Or you can look at energy as being sort of the opposite of money. And that the wealth that's generated that we have, and we've had the incredible luxury of living with, actually is mostly generated by the consumption of fossil fuels, the stored energy that's there. I think the part and impact on ecosystems is pretty clear. I think most people now know the food we eat is 10 times more fossil fuel than it is solar energy. So really, obviously with health food stores and others, but those may be delivered from long distances. So our food is that way. Our clothes are, most of us try and use more natural clothing, but just everything we do has got fossil fuels and has energy. I also did for a long time studies of settlement patterns of how we live together. Like the suburban whole context is pretty clear. It's a way of using oil that has actually created how our lifestyles are. That's true with coal, creating cities. So, for me, I began to realize that energy is like underneath. It's like if we look at the iceberg and we got all the little problems up on the top that we see, energy is like really huge in just much broader than we actually even can imagine, which also makes changing a lot harder. So the incredible part is, having started doing solar buildings in the 70s, when I can tell you that financially it was probably the dumbest idea you could think of from a financial perspective. It's amazing that, we now are in the place where I really think we are at the tipping point, that we in fact are in the renewable era as we speak today, and we haven't fully woken up to that. So this is that sort of transition point, and I think pretty obvious to everybody here that the path forward is huge amounts of efficiency so that renewables actually can take us take us forward and fossil fuels disappear. I think everybody here also knows the well-touted fact that in the United States it's close to 50% of the energy is in our buildings, which also relates to carbon and all of the other problems. So, for me, that's the part. If net zero buildings aren't so hard to do, which is my opinion, we can get rid of 40% of the problem and make a pretty big dent in the problem. Everyone here probably also knows, just in terms of net zero, the basics, which is you minimize the energy loads, all of the lights, the heating, plug loads, everything else inside your building. You power with renewables and you come up with net zero, or obviously you look for being net positive and creating more energy than you're consuming. A term that I'll use a lot, which probably people may know the jargon of, is net zero ready. That just means as architects we can design buildings to the energy conservation standard, and we can add the solar later, whether it's on the roof, whether it's on a carport, or whether it's in a gazebo, or whether it's off-site, or even from the utilities. I think probably most people are also familiar with, the house on the left. We can make net zero. It probably won't take the full desert full of PVs to make it net zero, but the balance point of how much PV to how much energy conservation is clearly important conversation. You'll probably hear me talking a lot today about weird things of EUI, which my guess is that everybody here actually knows about that. But it's pretty clear we all know the energy consumption of our car, and most of our clients have no idea of what the energy consumption of their building is, and no way of really comparing them from one to another. So we get from gas guzzling buildings or fuel guzzling buildings to Prius type buildings. I think also probably most people are fairly familiar with EUI. I mean, the sort of typical existing building is up around 100 in terms of thousands of BTUs per square foot per year. Code compliant may get down to around 50. High performance gets lower than that, and our net zero ready standard is being an EUI of between 15 and 25 in that sort of range, and then the rest is made up with PV. And that 15 to 25 EUI for me it doesn't cover process loads. So we'll be looking at the Proctor dining hall. I can tell you that it's not 25 to 50. I consider the kitchen a process load or manufacturing, laboratory buildings. But I think that range does really cover for residential, offices, general education. I mean, sort of typical buildings without high energy consuming uses. And for those who like our values, that's the sort of, I think now become quite common, the R60 roof, R40 wall, R20 below grade windows, and stopping air movement through the building at basically passive house standards is where that needs to go. I think most everyone's probably familiar with the basics of, you do the energy conservation we talk about, you still are going to have mechanical systems. Those need to be high efficiency, so they're typically heat pumps, whether air source or ground source heat pumps, and then you power the building with renewable energy. So here's what for me is amazing. I mean, again, going back to when none of this made financial sense, I've spent the last 10 years really looking at the finance part of it, because clients are enthused in general, or at least neutral. I mean, if you're going to do something better and it's not going to cost more, then people generally are going to do the right thing. Obviously, as architects, we hear more than anything else is it costs too much, can't do it. So the incredible transformation for me is that net zero buildings are less expensive now than fossil fuel buildings. The time has actually changed. So yes, the initial construction costs, I mean, in our experience, are $5 to $20 a square foot more. Yes, that comes out to 3 to 10% increased construction costs, so those are not sounding so good. Solar obviously costs a bunch of money, but it typically can be financed, although with Washington, some of that may change. But what it means is if you finance the increased capital cost for the building, it's a positive return on investment. If you look at the heat pumps, it's a positive return on investment. Not always, but typically. And the solar typically is a positive return on investment, at least it is today. So one of the things I did was we looked at what about a single family home? Let's just look at a single family home, because we get clients all the time saying, I really want to do net zero, but I just can't afford it. So we went to a modular company and said, okay, I want to buy a code compliant building from you, and I want to know the price to get a net zero building, both of which they offered. 1,600 square feet, that's the house. So I mean, the day that we did this, we could have had that done. So the additional cost was $16 a square foot for the building and $14 if you took the PV cost and put it over the square footage. So what does that mean if you're financing that on a 30-year mortgage? So you start off with 50 grand in additional building and solar costs. So that didn't actually sound so great. Then on top of that, you're going to finance it, so you're going to have finance costs. You're getting deeper in the hole. But there's what the energy costs are over 30 years. So what that comes down to is about a $60,000 savings in 30 years with tax credits, $72,000. And what that means, which I think is more incredible, is that the top line is the cost of the code compliant building, the bottom line is net zero, so the difference in between is the cumulative savings of the net zero building. You're getting that savings from the first day that you walk into your house. So it's costing you less money to actually do the net zero home. And after 30 years, the PV still is going to continue to work. It'll be reduced efficiency. So you're getting basically a free lunch after that. So, I now tell our residential clients is like, you can't afford not to do net zero. So that's great. We'll do all the single family homes, they'll be net zero, but what about bigger buildings and existing buildings? Is it really going to work there? This is the state of Vermont in Bennington, an office building. It's a 65,000 square foot renovation and addition that we did for the state. They had no intention of being a net zero ready building. That was not in the program, not in any goals, never even mentioned. We, however, did financial analysis of different options of what to do in terms of the skin of the building, and looked at the net zero ready option. It went up by $6 a square foot, 3% additional construction cost. And so if we compare that to if they'd kept the existing building, they would have had over 20 years, $6 million in energy costs. Going to the net zero actually saves $4 million over that 20 years. But if you compare it to if we'd done it code compliant and not net zero ready, there still is $750,000 savings to the taxpayers of Vermont in a 20-year period. So again, why wouldn't you do that? Again, this ends up being cash flow positive from day one with a 13% return on investment. And, back in the days of Jimmy Carter, everybody said this stuff is really ugly, doing these energy conserving buildings. This is the courtroom, I think when we and everybody else are doing net zero buildings, we actually are thinking about daylighting, connection to nature, materials, and all of the rest of it. Again, I think probably everybody here has heard in the past we focus on energy because it's at least reasonably easy to quantify. People still question that, but the fact is that when you look at this pie, all of the operations are less than 5%. The energy is probably half of that over the 20 or 30-year life cycle of a commercial building. So Its salaries, health, all of the other stuff is actually a lot more significant, and there is becoming more and more data in terms of resilience, stability, increased income, and that in fact those areas are of greater importance even in looking at. This shows at the time this was done, the study was done, the energy cost per square foot in commercial space was around $3 a square foot. The rent and mortgage, whichever it is, was more like 30. It's the sort of 110, 100 model. And the salaries were like 100 times more than what the energy costs were per square foot. So, what that means is if you save 1% in salaries, you're saving way more than you're going to get on the energy costs. And similarly, if you can get more rent for a better quality building or a lower energy consuming building, you've also got an advantage, and a lot greater advantage. So this is World Green Building Council, some of their analysis taking other data on the different pieces, that outside views improve mental function and memory. Call processing, they demonstrated that call processing was better, more efficient. The hospital stays is probably the one that's gotten the most publicity, I think, that people actually stay for a shorter period in the hospital if they have a view looking out at nature, or just, looking out the window with sunlight and whatever. That makes a big difference. Daylight, higher test scores, better learning, more productive. In retail, even Walmart did a study and demonstrated increased sales in the daylit part of their buildings. And then in systems, all of us, this is actually a great conference room, but we've all been in many conference rooms where you fall asleep. Probably not so good for your health. So all of those things actually are harder to specifically do the documentation of, but Vivian Loftus has in particular done a lot of work on that. So then this becomes the question, okay, so financially now, it's solved. What about, is this really a good place? Ultimately buildings are for people to live in. If we're not making buildings that are wonderful and beautiful for people to live in, then they're going to get torn down quickly, and we really haven't gotten anywhere. So this is just a single-family home, a lot of south-facing glass, views, connection to nature. Pretty nice, I think, pretty nice place to be. In Brookline, Mass, in a shingle-style neighborhood. The client wanted something that was fitting in with the shingle-style neighborhood. This is on a 45-degree angle because that's where south was in terms of the orientation, so designing the house so that all worked. Our offices and a 2-unit apartment in front of it are net zero historic buildings. In Maine, coastal Maine, botanical gardens, connecting to nature. The inside of the building with glass looking out both south and north, because connecting to nature was pretty important to them. The Putney School field house that is been net zero for, 6-7 years or something like that. The inside, again, daylighting. They looked at their whole campus and said, gee, we got a problem. We got 40 bad buildings. We've been working with them to actually, for like a 20-year master plan to make their whole campus net zero. UVM School of Natural Resources was in a building that was totally the antithesis of what their mission was. An 80s building with small windows, not a pleasant place to be at all. We did an addition and renovation for that project, which probably at the time it was done was one of the lowest, if not the lowest, college EUI of any building out there at the time, and it was a renovation project. This was a small addition on it, a solarium space, designed for a living systems ecological treatment system, but also as a place that becomes like a beach in the wintertime. Students around the campus come and hang out here as a warm and sunny interior environment. In Heinsberg, Vermont, a 75,000 square foot office and manufacturing facility. This actually uses wood pellets, so it's what we call carbon neutral. But a very high quality workplace that's literally had thousands of people from all over the world come to visit and saying, I can't believe we can do this at these larger sized buildings. We worked with them. They have 50 acres of land around the existing building. We worked with them on making a net zero 300,000 square foot master plan with office, manufacturing, residential, and commercial mixed use, saying we ought to look at a bigger scale. Actually can be net zero, cash flow positive also. So, you know, from all of that, our experience is net zero is totally achievable today. We can do it. The technology, there's nothing weird that we're doing. It's relatively established at this point. It's affordable. In fact, in many cases, less expensive than fossil fuel. And it's also beautiful. So, you know, our take is the time to do it is now.